Something else we always do on our exams is talk about relative sizes of things. You had a question on your quarter exam which asked about an estimation for a length or a thickness of your pencil. You had a ruler. You could have even measured it to figure out which measurement was most appropriate. We could ask you what's about how much mass is something in the metric system. So I'm giving you some masses here to help you. If you had a penny, hold on to it. It's going to be worth a lot of money soon because they're coming out of circulation. A penny is about 3 grams, 0.003 kilograms. If you have a textbook, they're about 2 kilograms. A bicycle is about 15 kilograms. A car is about 2,000 kilograms. If you have a jetliner, like a 747 jet, they're about 120,000 kilograms. If you're looking at a super tanker that goes across the ocean with cargo, we're talking about 150 million kilograms. So you can see they vary. They vary in size. Now, what I'm going to do is I'm going to give you a 1 kilogram mass to pass around. And we're going to pass it around every day for the next number of days. And so that way you can get a feel for what a kilogram is. I don't have it here. I think it's in the back. So you can get a feel for how heavy it is. This is a kilogram. Please don't drop it. You'll break the asbestos tile in the classroom on the floor, and then we have a big problem. This is a kilogram. Okay, this is a kilogram. 1 kilogram, you may want to put this in your notes, is about 2.2 pounds. So if we were to measure that weight of that here on the earth, it would be about 2.2 pounds. So pass it along so everybody gets a chance to feel how heavy that is. 1 kilogram is about 2.2 pounds. You go to Europe. I know when we go to, my family goes to Italy and we're at the delicatessen there and we're ordering deli meats or cheeses. In the United States, you would do that in pounds. Oh, can I get a quarter of a pound of this? Can I get a pound of my turkey breast? Can I get you don't do that there. You're doing it in kilograms. Kilograms. This is also really useful if you plan to go into the drug trade. Okay, illicit drugs, right? You hear on the news that they confiscated a kilo of this, a kilo of that. That's kilograms they're talking about. If you're planning to go into pharmacy, your tablets, everything is measured out in grams, metric grams. What is it, right? Okay, my allergy medication that I take, Zyrtec, is a 10 milligram tablet. Milligrams. It's okay. It's small. It's little. 1 gram is 1 paperclip. You might want to write that down too to help you remember things. A gram is a paperclip. A textbook is 2 kilograms to give you rough ideas. On Tuesday, we will be figuring out what your mass is in kilograms. It's a good measurement to know in case you ever travel outside of the United States. Because if you happen to get ill and need to go to a doctor or a hospital anywhere else outside of the United States, you want to be able to tell them your mass. Okay, so we'll be looking at doing that using your weight in pounds. All right, so let's talk about some examples of how the first law behaves. I want to see if you can explain to me why these things happen in terms of Newton's first law. So the first scenario says that blood would rush from your head to your feet if you are quickly stopping in a descending elevator. So the elevator is going down to the ground and it's going to stop very quickly. You're going to feel a little lightheaded because the blood in your body will rush from your head to your feet. My question is, can you explain why that happens in terms of Newton's first law? I'll get you started. Because an object in motion wants to keep moving. Were you moving before you stopped? Yeah. Was the blood inside of you moving? Yeah. The blood is separate from your outside body, which means that even though your body stopped, the blood kept moving, and it kept moving in the direction you were headed, down. That is why the blood rushed from your head to your feet. Even though your body stopped, your blood did not. An object in motion wants to keep moving. That would be the explanation you would write to explain that. How about this scenario? The head of a hammer can be tightened onto the wood handle if you bang the bottom of the handle against a hard surface. So here's what we're talking about. Here's a hammer where the head and the handle are two separate pieces. Can you explain why the head would get tightened onto the handle if you bang it onto the desk several times in terms of Newton's laws? One?
Because you're moving both parts at the same time, but stop the one part so the metal part keeps going down.
Right, because an object. Bingo. So even though this stopped, that was moving, it wants to keep moving. Wants to keep moving downward and gets tightened on there. Can you explain this? To dislodge ketchup from the bottom of a ketchup bottle, often you will turn it upside down and thrust it downward at a high speed and then stop it. You know what I'm talking about. To get it to come out. Why would that dislodge the ketchup from the bottle? Explain that in terms of Newton's laws. Yeah. Because an object, there you go. The ketchup was in motion. It wants to keep moving even though the bottle around it stopped. Headrests are placed in cars to prevent a whiplash injury during a rear end collision. All right, let's talk a little bit about safety. How many of you have your license right now? How many of you are hoping to get it at some point in the near future? All right. As the driver of a vehicle, I'm going to tell you right now, whenever you're the driver of the vehicle, you are responsible for your safety and the safety of all of your passengers. You have an accident, it is on you. You were the driver. You are the driver. You are the one responsible for making sure they're all safe. Okay, it doesn't matter who's in the car with you. So let's imagine we have this seat in the car. Does this seat have a headrest on it?
No.
Okay. Let's talk about what happens in a collision, a rear end collision, if you don't have a headrest. Okay. First of all, what is whiplash? Whiplash, I'm going to explain to you. Nope, it's not this back and forth kind of thing. That is not what whiplash is. Whiplash is an injury that is caused by a rapid compression of the vertebrae in your neck. Do you all know that your spinal column goes up to the stem of your brain? It comes all the way up back here and goes to your brain stem. And there are all these little discs and vertebrae. The discs are cushions of fluid in between each vertebrae. Now, what happens in a whiplash injury is the vertebrae on the disc. And what do you think happens to the fluid in between those vertebrae? And where does it go? Out. You have no more cushioning between bone and bone. So what happens when you have bone on bone? It hurts a lot, and it cannot be fixed without spinal surgery. Who wants to have spinal surgery? Nobody. Even spine doctors don't want to do it because it is extremely dangerous, especially the vertebrae near your brain. Nobody wants that. So here's what happens. Without the headrest, rear end collision means here I am and I am stopped. I am stopped. Rear end, somebody comes up from behind me and hits me. So what does the car do? It goes forward. My seat is going to go forward. Is my entire body being pushed forward by the seat? No, it's not. Only up to my shoulders, roughly, is going to get pushed forward. My head and my body were at rest initially. What does my head want to do if it's at rest? It wants to stay at rest. It wants to stay behind. But my body, from my shoulders down, gets pushed forward very quickly. So it looks like this. Although your head isn't snapping back, what really happens is your body is pushed forward, but your head doesn't move, causing that to happen in your neck. Do you follow? How would a headrest fix that? Right. It keeps your head moving with your body. So it extends the seat all the way up behind your head. So now if the seat gets pushed forward, your entire body moves forward. So that way your head doesn't stay behind. And now you've prevented the whiplash injury. So as the driver of the car, you need to make sure everybody's headrest is positioned correctly behind the head. Now, I don't know how many of you, if you're driving and you have your own license, have your own vehicle. Chances are you probably don't. I know when my daughter gets her license later this year, she's not going to have her own car. She'll borrow my car. And she is quite a bit taller than I am. So that means when we swap drivers in the car, she's going to have to make sure that she moves the headrest up in the driver's seat. You follow? Otherwise, if she gets in an accident, she's not going to be as protected. So we have to adjust. You may have to continuously adjust those things to make sure everyone in the car, including yourself, is protected in this type of injury. They're not fatal. They're just permanent neck damage. Permanent. It's not fun. And you guys are too young to have that. You'll have arthritis like immediately. It's bad. And you see people wearing these collars, right? That's to try to prevent any more pain. All right. How about this one? What motion would the passengers in a car undergo if they failed to use their seatbelt and there were no airbags in the car either, and the car is brought to a sudden and abrupt halt by a collision with a wall? So you're not wearing your seatbelt. There's no airbag. You're driving along and all of a sudden you go into a wall. What's going to happen and why? Janicia? Yeah, usually you go through the windshield head first. Imagine how that is. Is that good? No, not at all. Usually it's fatal. Usually it's fatal. This injury is fatal because a body in motion wants to keep moving. So you are going to keep moving even though the car stopped, and you'll go through the windshield. This actually happened to a cousin of mine, my cousin Jonathan, who at the time he was 21 years old. He is now 45. He did not die. He was coming off the Northway. He lived in Latham, coming off the Northway at exit 4. And at the time, exit 4 and 5 were kind of together. And they did some construction on that area a few years ago. But he was coming off the southbound exit ramp, going too fast in his little sports car that he had bought, little beater sports car, and was not wearing a seatbelt. And because it was an older vehicle, it didn't have an airbag. Came off going too fast around a turn, couldn't navigate the turn, went into a tree. Same idea. His head went straight through the windshield. He got stuck in the windshield. It was right, you know where the Colony Police Department is? Okay. The Northway is on the other side of the trees that are there. That's where it was. It was right there where those trees are. So the Colony Police could see it, but could they do anything about it? No, because that's a state highway. They had to wait for the state police to show up, and then they called the Jaws of Life. And he was brought by helicopter once they got him out from there to Albany Med. What was happening to him on the way during the flight was his blood pressure was going through the roof because his brain started to swell. He basically got a massive concussion. That's a big, big, big brain bruise. When you get a bruise, things start to swell, and inside your skull is a bone. Does that allow your brain to swell? No. So the pressure inside his brain started to go up really high, which would cause a stroke unless they were able to relieve that pressure by removing a piece of his skull. And that's exactly what they did when he got there. They cut him open from here to here, opened him up, cut out with a saw a top part of his skull. Then they sutured him back up, and he was placed in a medically induced coma because the pain would be excruciating. And they had to wait 6 months for that swelling to come down. He was in a coma for 6 months until the swelling got reduced enough that he wasn't going to stroke out. At that point, he didn't have the top of his brain. He then went, once he woke up from the coma, the swelling was down, woke up, and they opened it back up, put the bone back in. So now they fused the bone. And then he was transferred to Sunnyview Rehabilitation Hospital because he had a traumatic brain injury. If you were to meet my cousin Jonathan today, you would wonder what is wrong with this man. Something isn't right. He had to learn how to walk, talk, eat with a fork all over again. He had to learn how to go to the bathroom again. He had to learn how to do everything all over again. If you were to talk to him today, you would think you were talking to a 5-year-old boy. And he's 42. He is on permanent disability. He has grand mal seizures every day. It's bad. It's bad. During that 6 months, my family and I we go to church. We were just praying that almost. It was hard. It was hard for us to watch. It's hard for us to watch him now. He will never be able to live on his own. Ever. Ever. And his mother is 76 years old. She's not going to live forever. What happens to him after she passes away, I do not know. It's bad. It's bad. You need to make sure you wear your seatbelt. And as the driver of the vehicle, who's responsible for making sure everybody in the car is wearing their seatbelt? You are. You are. Unfortunately, it's almost every year that I have to go to a former student's funeral that got into an accident like this because they were in a rush, didn't put their seatbelt on, and they died. We almost wish he had passed away. It's bad. It's bad. Not saying his quality of life, it just doesn't have the same quality of life anymore. But he is alive. He's on a lot of medication, on disability, can't hold a job, can't do any of those things. And he was 21 when that happened. He was attending Hudson Valley to be a computer technician. He had a good job lined up, and that was taken away like that. And we'll never be able to do that. So I'm telling you that because I want to make sure I don't go to your funerals. Okay, when I got to pass away before you, that's the natural order of things. You can come to mine, but I should not be going to yours. So please just make sure you wear your seatbelt. And it is the worst thing. I did have a student my 3rd year of teaching who got into this accident. Him and his passenger, he was wearing a seatbelt. His passenger was not. There was an accident here at the high school. They were driving at around 11 o'clock at night. He was navigating the turn over by the football field too quickly. Went straight into at that time they had these concrete ballast posts around the football field, and his car went right into those concrete posts. The car stopped. His passenger went through the windshield. She died. He was 16 years old when that happened. Do you think he was ever the same after that? Can you imagine your passenger and your car died as a result of what you were doing? Okay, so please make sure you are responsible drivers. That's all. It's my public service announcement today, and that's all because of physics. All right, that's all I got for you on this presentation. We have 10 minutes. I would like to go through some of the practice questions with you in your Unit 6 packet. They are all conceptual. Can you explain this stuff? Okay. Sorry for the gory lesson. I know some of you are like, oh my God. Just the visualization is really yucky. Here we go. Number 1. Imagine a place in the cosmos where we are far from all gravitational and frictional influences. Suppose an astronaut in that place throws a rock. What does the rock do? Does it gradually stop, or does it keep moving in the same direction at a constant speed? 1? Yeah, in a straight line. That's right. Because an object in motion will keep moving in a straight line at a constant speed when the forces are balanced. Now, in this case, you might be going, wait a second, the forces are balanced. Here's that rock. Are there any forces on that rock at all? None. No forces is like balanced. There's not, it's all balanced. There's just nothing there. It's not unbalanced, so it's got to be balanced. Okay. This was traveling and it will remain moving at a constant speed. Straight line. Number 2. A 2 kilogram object is moving horizontally with a speed of 4 meters per second. How much net force is required to keep the object moving at that speed in this direction? All right, here's a term that you need to know. Net force. Net force refers to the amount of unbalanced force. If you have a net force, it means the forces are unbalanced. How much unbalanced force do you need to keep something moving at that speed in that direction? It's not a trick question. How much? You want something to keep moving at a particular speed in a straight line. How much do you need? No. None. So that means, and the symbol for this is F net is 0 newtons. You don't need any unbalanced force. The forces must be balanced. You need balanced forces, not unbalanced. Number 3, Mac and Tosh are arguing in the cafeteria. You get the names? Mac says that if he flings the apple. Here we're going to say flings the Jell-O with a greater speed, it has a greater inertia. Tosh argues inertia does not depend on speed, but rather on mass. Who do you agree with and why? And please don't do this at home. Please don't do it in the cafeteria here at school. Don't say, I was trying a physics experiment. Miss Famoso told me to do this. No, I'm not. Do not do it for real. Who do you agree with? Who is correct? Mac or Tosh? Janicia? That is correct. Why? That is correct. Inertia depends on mass only. Number 4, if you were in space in a weightless environment, would it require a force to set the object in motion? So think about it. My pencil's in space. It's just floating there. It's at rest, right? Do I need to have a force to make it move? Yeah, of course, because now you're changing its motion. An object, not in rest, at rest, will stay at rest unless an unbalanced force is applied. So yes, you are going to need to apply an unbalanced force to change that motion. Number 5. Again, don't do this at home either, but next weekend we'll give you a little bit of a reprieve on that. John Madden is spending most Sunday afternoons at rest on the sofa, watching pro football games and consuming large quantities of food. So he's at rest on the sofa eating a lot of food while he watches football games. What effect, if any, is that going to have on his inertia? Nikolai? That's right. So the inertia will increase due to his increase in mass. Now, John Madden, I'm not sure if he's still alive or not, but he used to be one of those pro football announcers on ABC Sports. I'm not so sure he's still doing that or not, but he was a big guy. Or he was a real big guy anyway. All right, let's go to number 6. Ben Too Close is being chased through the woods by a bull moose, which he was attempting to photograph. The enormous mass of the bull moose is extremely intimidating. Yet, if Ben makes a zigzag pattern through the woods, he's able to use the large mass of the moose to his own advantage. Explain that in terms of inertia and Newton's first law of motion. You get his name? Yeah. Why is the bull moose trying to chase him? Because he got too close. Yeah. He's been too close. All right. So Ben is going to zigzag through the woods to get away from this bull moose who's chasing him. I mean, a bull moose is probably 6.5, 7 feet tall, plus the antlers on top of that. So how does this work? He's going to zigzag. What is the moose probably going to try to do? So the moose is also going to try to zigzag. Is the moose going to be able to do that? No, why not? What? He has too much mass. And the more mass he has, what? The more inertia. So that means it's, keep going with that thought. I already heard that. So what does that mean? It's harder to change. The moose is going to have a much more challenging time zigzagging than Ben. So since the moose has more mass, it has more inertia and will have a more difficult time changing directions, meaning zigzagging. So Ben can escape without injury. You could do that with any animal in the woods. Let's say you go camping and you come across a bear. The bear starts chasing you. You start zigzagging. And that's how you'll get away. All right.